students, you understood what is today's topic? Correct. Drawing a histogram. So let us start. As we know that the histogram is a graphical representation that organizes a group of data points into user specified ranges. It is similar in appearance to a bar graph. It looks like a bar graph, but there is a difference between bar graph and histogram. The histogram condenses a data series into an easily interpreted visual by taking many data points and grouping them into logical ranges or bins, that is values. Do you know whose picture is this? This is the inventor of histogram, Carl Pearson. A histogram, it is an approximate representation of distribution of numerical data. It was the first introduced by Mr. Carl Pearson. In this, the class intervals must be adjacent and are often of equal size but not required to be. So we know that a histogram is a graphical representation of a continuous data using the bars where no gap between the bars. So let us learn how to draw. So let's exercise 14.3, question number 5. The following table gives the lifetime of 400 neon lamps. First of all, we have to draw the histogram for the given data, as well as we have to write the answer for how many lamps have a lifetime of more than 700 hours. So here, this is the table. We have to take the two axes, perpendicular y-axis and horizontal x-axis, and as we know that on the graph paper there is the squares. The graph paper consists either squares. So these squares, we assume that these are the 1 unit length, and by observing the number of lamps we can understand what value we have to take on the y-axis to represent the given data appropriately. So on the y-axis we take the frequencies, that is number of lamps, and on the x-axis we take the lifetime, that is the class interval. Now observe that frequency is given. Yes, we observe and understand that if we represent 1 unit is 10 lamps, so easily we can represent all these frequencies on the graph. So we take 1 unit is like this, and on the x-axis also we have to take 1 unit is 300, then next is 400, 500, 600, 700 and so on. Now first rectangle we have to draw, that is 300 to 400 is height 14. So after 10 there are 4 small lines, represents 14. So 14 is the length of 300 to 400 lifetime, that is in hours. For second rectangle 400 to 500, that is 56. So from 400 we have to start the rectangle up to the 500 where its height is 56, that is after 50 there is 6 lines, represents 56. Next 500 to 600 our rectangle will be start and its height is up to 60, so up to 60. Then next 600 to 700 its height is 86, that means after 80 there are 6 lines on the graph paper, so we have to draw the rectangle up to the height 86. Next is 700 to 800, its height is 74, after 70 there are 4 lines, small lines, so it is 74. Next is 800 to 900, there is 62 is the height for the rectangle, so 62, that means 60, after 60 2 lines we have to consider, shows 62. 900 to 1000, 48 we consider 40, then after 40 8th line shows 48, which is between 40 to 50. So in this way we have drawn the histogram for the given data. Now we have to write the scale which is on the topmost right hand side corner, 1 unit, it is equals to 1 centimeter is 10 lambs. So this is the representation of given data into the histogram. And second, we have to write the answer for how many lambs have a lifetime more than 700 hours. So we have to observe the lifetime 700 to 800. There are three values, 700 to 874, then 800 to 962, and 900 to 1048. When we add all these three, we get the number of lambs whose lifetime, where the lifetime of the number of lambs is more than 700, is 74 plus 62 plus 48, that is equals to 184. Now one thing we have to remember, this king or this jagged line, as we know that from 0 to 300, in these the distance between 0 to 300 is not equals to the distance between all the class interval, and also this 0 to 300, these values we don't require. So values we don't require from 0 to 300, we show these are the values which not required by showing this jagged line or this king. Now in the same way, there is one more representation of data like this. It is known as frequency polygon. So let's talk about that also. The frequency polygon, a line graph, is drawn by joining all the midpoints of the top of the bars of histogram. Frequency polygon are graphical devices for understanding the shapes of distributions. They serve the same purpose as histogram but are specially helpful for comparing sets of data. Frequency polygons are also a good choice for displaying cumulative frequency distribution. So here, this meaning the frequency polygons are also same as the histogram, but it is very convenient way to represent or compare the two sets of data. So how to draw it? A frequency polygon can be created from the histogram or by calculating the midpoints of the class intervals from the frequency distribution table. The midpoint of an interval is calculated by adding the upper and lower boundary, or we can say limit, values of the class interval and dividing by the sum by 2. So in this way also we can draw the frequency polygon. Let's understand the drawing of a frequency polygon using the histogram. So we consider the previous example. In the previous example, we have drawn this histogram for the given data, lifetime of number of lambs. In the same, we have to draw for the frequency polygon, and what is said that we have to take the midpoints of the top of the rectangles like this. This is the midpoint of the first bar, this is the midpoint of the second bar, this is the midpoint of the third bar. Like this we have to take the midpoints of the bars, and then after getting all the midpoints of all the bars, we join all these midpoints in this way. So we get this curved line or this line graph, which is the frequency polygon, where we have drawn all the midpoints of the frequencies. Now what is the ending and starting point of this frequency polygon? This dotted line shows the frequency polygon. So here, as we have drawn the midpoint of this 300 to 400 of this class interval, so from 0 to 300, before this 300 there is 200. So its midpoint 200 to 300 will be 250. So this starting midpoint of this first class interval will be on the x-axis, which is for the 250, and similarly from 1000 to 1100 there is the midpoint is here, so we join this endpoint of this frequency polygon to this point. So this shows the midpoint of the 1000 to 1100 or 1100. So like this we have to draw the frequency polygon by taking the midpoints of the class intervals, and by joining these midpoints of the class intervals, which are the curve which shows the frequency polygon. So I hope you understand how to draw the frequency polygon and the histogram.